All right, part 3, decimal multiplication. Here we go. Rule 1, do not line up the decimals. Yes, we are in a totally different world than decimal addition and decimal subtraction. 3 is very, very different than 3 and 3 Decimal addition and subtraction are kind of like mirror images of each other. Decimal multiplication, the rules are totally different. So whatever you learned with 3 and 3 keep it in 3 and 3 3 and 3 multiplication and division are new moves. We have new strategies and new algorithms for these new issues. So yeah, rule 1, do not line up the decimals. Rule 2, put the number with fewer digits on bottom. We'll go over that in a minute. Rule 3, count up the decimal places at the end. And rule 4, estimate to check. Let's get going with 3.4 times 7.28. So what do we do first? We put 3.4 on the bottom and we do not line up the decimal points. 3.4 is on the bottom because what we're going to have to do is do 4 times 8, then 4 times 2, then 4 times 7, then 3 times 8, then 3 times 2, then 3 times 7. So it's easier if the number with the fewer decimals is on, fewer digits is on bottom. And we don't have to line up the decimal places. We can leave it like this. Now, like I just said, what we're going to have to do is we're going to have to do 4 times 8, 4 times 2, 4 times 7. And there are two types of people out there. There are people who know their multiplication tables really, really well, and people who know them less well. No matter what type of person you are, you can be successful with decimal multiplication, even if you don't know what 8 times 4 is. How? Because you're gonna build yourself a ladder. Look what I did over here. All I need to know is addition, and I can build myself a ladder. 4 is 4 times 1. It's 4 one time. 4 plus 4 is 8. That's 8. 8 is 4 times 2. It's 4 twice. Then we add another 4. That'll be 4 3 times. 8 plus 4 is 12. 12 is 4 times 3. It's 4 3 times. 16 is 4 4 times. 20 is 4 5 times. And I'm just building a ladder by adding by 4. Everyone here can add by 4. Build your ladder and add by 4. And you know what you're going to get? You're going to get 40 for 10 fours, which makes sense because 10 fours is the same as 4 tens, and that's 40. 4 and then a 0. So you know you got it right. Do that, and you have 8 fours for 32. So we have this to help us if we need the help. It's just like a multiplication table. Well, it's the stack of 4s. And here I have the stack of 3s to help as well. So that will help me get going, and I'm going to refer back to these two ladders whenever I need to do so to do these math problems. All right, so let's get going. 4 times 8 is 32. Put down the 2, carry the 3. 4 times 2 is 8, plus 3 is 11. The 1 goes here, the 10 goes here. So put down the 1, carry the 1. 4 times 7 is 28, plus 1 is 29. 29, 12. That's 4 times 8, 2, and 7. 2, 9, 12. Now what we're going to do when we move down to the 3 is we're going to scratch out these numbers that we carried because we don't want to get confused. And we need to do a placeholder because when we multiply with the second digit to the left, there's going to be a placeholder here. 3 times 8 is 24. Put the 4 here under the 1. Carry the 2. 3 times 2 is 6 plus 2 is 8. And 3 times 7 is 21. So 21 goes here. And now we have 2, 9, 1, 2 on top, 2, 1, 8, 4 spaceholder on bottom, and we add them. 2 plus placeholder and 0 is 2. 1 plus 4 is 5. 9 plus 8 is 17. Put down the 7, carry the 1. 1 plus 2 plus 1 is 4, and 0 plus 2 is 2. 2, 4, 7, 5, 2. Those are the right digits in the right order, but where does the decimal point go? This is what I meant when I said earlier that rule 3 was counting up the decimal places. We have 2 decimal places up top and 1 decimal place down below for a total of 3 decimal places altogether. So we're going to bring back the decimal point from the right, jumping left 3 hops, and it goes right there. The final answer is 24.752. But let's use estimation just to give a check, because checking your work is important. We did so much math here. It seems like one math problem, but really it's like 20 math problems, right? We did a lot of multiplication, a lot of addition, and we moved that decimal point. So we just want to make sure it makes sense using estimation. So how do we use estimation? Well, we use it like this. 7.28 is kind of like 7 and a little more. 3.4 is kind of like 3, only a little more. 7 times 3 is 21, so the answer of 7.28 times 3.4 should be a little more than 21. 24.752 makes sense. If you put the decimal point here and got 247, you know you would get it wrong. That's how you use estimation to double check your answer. 24.752 makes sense, and we're good to go, but we got to practice.